Welcome back to another video by Adeptis Academy. Every day, as we go about our lives, we rely on a constant and steady flow of power. From the moment we wake up and switch on the lights, to the time we go to bed with our devices charging beside us, energy is the invisible force that keeps our world running. Our demand for power grows every year. As our cities expand and our technologies advance, the need for more energy becomes ever more pressing. We are constantly seeking new ways to generate and consume power more efficiently. We need a reliable, sustainable source to meet our needs. Renewable energy sources like wind and solar are making significant strides, but they alone cannot meet the growing global demand. We need a diverse mix of energy solutions to ensure a stable and sustainable future. Nuclear engineering offers a powerful solution. It provides a high-output, low-carbon energy source that can operate continuously, regardless of weather conditions. This makes it a crucial component in our energy mix. Nuclear engineering is the key to unlocking the immense energy within atoms. By harnessing the power of nuclear reactions, we can generate vast amounts of energy from a relatively small amount of fuel. This efficiency is what makes nuclear power so compelling. This field is not just about power plants, though. Nuclear technology has a wide range of applications that extend far beyond electricity generation. It plays a vital role in medicine, industry, and even space exploration. It touches many aspects of our lives. In medicine, nuclear technology is used for diagnostic imaging and cancer treatment. In industry, it helps with material testing and quality control. And in space, nuclear power enables long-duration missions far from the sun. It's about pushing the boundaries of science and technology. Nuclear engineers are constantly innovating, developing safer and more efficient reactors, and exploring new ways to use nuclear energy for the benefit of society. It's about creating a brighter future for generations to come. By investing in nuclear technology, we are investing in a cleaner, more sustainable world, a world where energy is abundant, reliable, and environmentally friendly. Nuclear engineering is a specialized field of engineering. It focuses on the power of the atom. This power can be harnessed for many applications. Nuclear engineers are problem solvers and innovators. They design, build, and operate nuclear facilities. These facilities include power plants and research reactors. They also work on medical imaging equipment and other nuclear applications. Their work is crucial for our energy security, health, and technological advancement. At its core, nuclear energy comes from the atom's nucleus. This nucleus is composed of protons and neutrons, tightly bound together by strong nuclear forces. These forces are incredibly powerful, and when manipulated correctly, they can release a tremendous amount of energy. This tiny center holds immense energy. The energy stored within the nucleus is due to the binding energy that holds the protons and neutrons together. When this binding energy is released, it can be harnessed for various applications, from generating electricity to powering spacecraft. Nuclear engineers have found ways to release this energy. Through years of research and development, they have designed reactors and other technologies that can safely and efficiently tap into the power of the atom. These advancements have paved the way for the widespread use of nuclear energy in many sectors. There are two main ways to release nuclear energy: fission and fusion. Fission involves splitting a heavy atom into smaller parts, while fusion involves combining light atoms to form a heavier one. Both processes have their unique advantages and challenges. Fission is like splitting wood. You break apart a heavy atom. This process releases a significant amount of energy, which can be used to generate electricity. Fission reactors are currently the most common type of nuclear reactors in operation around the world. Fusion is like combining two drops of water. You join light atoms. Fusion has the potential to provide even more energy than fission, with fewer radioactive byproducts. However, achieving the conditions necessary for sustained fusion reactions is extremely challenging and is the focus of ongoing research. Both processes release huge amounts of energy. The energy released from nuclear reactions is millions of times greater than that from chemical reactions, such as burning fossil fuels. This makes nuclear energy a highly potent source of power. This energy can be harnessed for various uses, from generating electricity for homes and businesses to powering submarines and spacecraft. Nuclear energy has a wide range of applications. As technology continues to advance, the potential uses for nuclear energy are likely to expand even further. Nuclear fission is the process of splitting atoms. Imagine throwing a neutron at a uranium atom. The uranium atom becomes unstable and splits. This splitting releases energy and more neutrons. These neutrons hit other uranium atoms, causing a chain reaction. This chain reaction is controlled in nuclear reactors. This controlled reaction produces heat. The heat turns water into steam, which spins turbines. These turbines generate electricity in power plants. The Sun, our closest star, is a massive nuclear reactor, constantly undergoing nuclear fusion at its core. Nuclear fusion is the process powering the Sun and stars. This process occurs under extreme temperatures and pressures, where hydrogen atoms collide and fuse together. It involves combining light atoms like hydrogen to form helium. During this fusion, a small amount of the mass of the hydrogen atoms is converted into energy, according to Einstein's famous equation E=mc². This process releases incredible amounts of energy. The energy produced by fusion in the Sun is what provides the light and heat necessary for life on Earth. Fusion has the potential to be a nearly limitless energy source. Unlike fossil fuels, which are finite and polluting, fusion fuel is abundant and clean. It produces very little waste and doesn't contribute to climate change. The byproducts of fusion are not only minimal but also non-toxic, making it an environmentally friendly option. However, achieving controlled fusion on Earth is a major challenge. The conditions required for fusion are extreme, and replicating them in a laboratory setting is incredibly difficult. Scientists are working on fusion reactors, but they are still in the experimental stage. These reactors aim to create and sustain the high temperatures and pressures needed for fusion, but there is still much work to be done before fusion can become a practical energy source. International collaborations and significant investments are driving the research forward. Projects like ITER in France are at the forefront of this scientific endeavor, bringing together the brightest minds from around the world. If successful, nuclear fusion could revolutionize the way we produce energy, leading to a future where clean, sustainable, and virtually limitless power is available to all. The power of the stars could one day be harnessed here on Earth, transforming our energy landscape forever. Nuclear energy has numerous applications beyond electricity generation. It plays a vital role in medicine, industry, and scientific research. In medicine, nuclear technology is used for diagnostic imaging, like PET scans and cancer treatment. In industry, it's used for material testing and food preservation. Researchers use nuclear reactors to produce isotopes for various applications. These isotopes are essential for medical treatments, smoke detectors, and more. Nuclear engineers work in diverse environments. They might be found in power plants, research labs, or government agencies. They often work in teams, collaborating on complex projects. Their tasks vary depending on their specialization. They might design reactor components, develop safety protocols, or analyze data from experiments. A strong background in math, physics, and engineering principles is essential. Nuclear engineers also need excellent problem-solving and communication skills. Nuclear engineering faces both challenges and opportunities. Public perception, waste disposal, and the risk of accidents are ongoing concerns. However, advancements in reactor design, safety protocols, and waste management are constantly being made. Nuclear energy offers a low-carbon solution to climate change. The development of fusion power holds immense potential for a clean energy future. Nuclear engineering will continue to play a vital role in shaping our world. Nuclear engineering is a field of immense importance. It unlocks the potential of the atom for energy, medicine, and scientific advancement. While challenges remain, the future of nuclear engineering is bright. With continued research and innovation, we can harness the power of the atom safely and sustainably. Nuclear engineers are at the forefront of this exciting field, shaping a better and brighter future for generations to come. As we look towards a powerful future, it's essential to understand the rewards that come with a career in nuclear engineering. One of the most tangible rewards is the salary. On average, a nuclear engineer in the United States can expect to earn between $80,000 and $120,000 per year. However, this range can vary significantly based on several factors. Experience is a major determinant. Entry-level nuclear engineers may start at the lower end of the salary spectrum, but as they gain more experience and expertise, their earning potential increases. Senior-level engineers and those in managerial positions can earn well over $150,000 annually. Education also plays a crucial role. Engineers with advanced degrees, such as a master's or PhD, often have higher earning potential than those with just a bachelor's degree. Specializations within the field, such as nuclear power plant design or nuclear medicine, can also influence salary. Location is another critical factor. Nuclear engineers working in areas with a high demand for their skills, such as states with numerous nuclear power plants or regions investing heavily in nuclear research, tend to earn higher salaries. For instance, engineers in California or New York might earn more than their counterparts in states with fewer nuclear facilities. In conclusion, a career in nuclear engineering not only promises the opportunity to contribute to significant advancements in energy and technology, but also offers a competitive and rewarding salary. As the field continues to evolve, the demand for skilled nuclear engineers is expected to grow, making it a promising career choice for the future.